Welcome to this lecture on Assorted Examples of Lattices by Dr. Rajesh Singh.
Good afternoon, sir. Good afternoon, sir.
Good afternoon, Sakshi and Ranjim. So what we did last time?
So complete lattice and some theorems based on lattice.
Yes, we defined lattice, then we did some results with examples of lattices, then we did one example of complete lattice, right? So on that line only, we will proceed with another example of complete lattice today. Okay, fine. So the result that we are going to do today is this theorem. So let X be any set, okay, then the post set Px with inclusion relation is a complete lattice. So we have to show that this is a complete lattice. So how to prove this? It is a complete lattice. Yes. कंप्लीट लैटिस शो करने के लिए क्या करना होता है हमें?
We need to show that theorem and theorem exists.
So we will take any arbitrary subset of Px, right? We will take any arbitrary subset of Px, and then we will show that the cup and the join and meet of that set is again in this set, right? So that we have to show. So so we can start with this. So let S contained in Px be any arbitrary set. Okay. So if S is contained in Px, then what is the set S of the form? S में S किस तरह का सेट होगा? S के अंदर एलिमेंट कैसे होंगे? If S is a subset of Px, what are the types of element that will be there in S? Yes, so what is this set S of the form? Can someone explain? इसके elements कैसे होंगे? S is a subset of power set of X. So what kind of elements will be there in S?
Subsets of X.
Yes, subsets of X. Yes. So then S is equal to AI, I belonging to I, right? For some इंडेक्स सेट आई, राइट? कोई ऐसा आर्बिट्री सेट होगा आई जिसके मतलब उसके कोरस्पॉन्डिंग हमारे पास बहुत सारे सेट्स आ जाएंगे, ठीक है? बिकॉज वी डोंट नो व्हाट हाउ मेनी सेट्स आर देयर इन पीएक्स, सो कितने एस के अंदर है वो भी नहीं पता, सो वी हैव गिवन एनी आर्बिट्री इंडेक्सिंग फॉर एआई. ओके, so then claim is, what we will claim, we will show that supremum of this s will be, what will be this, क्या होना चाहिए, क्या एक्सपेक्ट करते हो? अगर कोई दो सेट है तुम्हारे पास ए कब बी, तो व्हाट शुड बी दिस? What will be the maximum of these two? Supremum of these two? If you have two sets A and B, then what should you expect the maximum to be? मतलब
Union of A and B.
Yes, because what A union B is the smallest set containing both A and B, right? So it should be A union B, and A cap B should be A intersection B, because A intersection B is the largest set contained in A and B. Okay. So on the similar lines, we should expect that it should be union I belonging to ai, matlab union of all these ai's, right? And infimum of S should be intersection I belonging to ai. And this being because all ai's are subset of X, so this is also a subset of X. This is also a subset of X, so it will belong to Px. So we just need to show that the supremum of S is equal to this and infimum of S is equal to this. And because if we will prove that supremum of S is equal to this, then we can directly say that dually this will happen. So we just need to show that this is true. Okay. So to prove our claim, we just need to show that, ये तुम्हें लिखने की वैसे उतनी ज्यादा जरूरत नहीं है, but इसलिए मैं लिख रहा हूँ क्योंकि तुम्हें समझ आए. We just need to show that this is equal to union I belonging to ai, since this intersection I belonging to I can be obtained dually. ठीक है, या can be obtained from duality principle. Okay. ये चलो ये मत लिखो, इसको हम बाद में लिख देंगे डुअली, जैसे सिमिलरली लिखते हैं वैसे ही नीचे लिख देंगे, अभी मत लिखो इसे. लेट अस ट्राई टू शो दैट. अब इसको शो करने के लिए क्या करना होगा हमें? सुप्रीमम ऑफ S इज इक्वल टू दिस, व्हाट वी विल हैव टू शो? यस, सुप्रीमम शो करने के लिए क्या करना होगा हमें? सुप्रीमम की डेफिनेशन क्या होती है? इट इज एन अपर बाउंड एंड इट इज लीस्ट अपर बाउंड. सो फर्स्ट वी हैव टू शो इट इज एन अपर बाउंड. अपर बाउंड शो करने के लिए क्या शो करना होगा? बताओ.
S is contained in AI.
नहीं, S नहीं, एवरी एलिमेंट ऑफ S इज कंटेन्ड इन यूनियन AI. ठीक है, S नहीं. अपर बाउंड का मतलब क्या होता है? अगर सेट के अंदर हमारे पास कुछ एलिमेंट्स हैं तो हम यही तो शो करते हैं ना कि X is an upper bound of S. X is an upper bound of S if and only if A is related to X for all A belonging to S, right? So अब यहाँ पे क्या है कि X की जगह हमारे पास this सेट है, यहाँ पे लेस देन इक्वल टू की जगह कंटेनमेंट रिलेशन है और A की जगह हमारे पास सबसेट्स हैं, AIs हैं. So we will have to show that each AI is contained in this union. And is it true? So clearly,
Yes, sir.
for each I belonging to I, AI is contained in union I belonging to AI by definition of union. So this implies union I belonging to AI is an upper bound of S. Next, what we have to show? We have to show that it is the least upper bound. So we will take any other upper bound. So let K belonging to Px be any upper bound of S. So this implies AI is contained in K for all I belonging to I. So, okay, because this is an upper bound, so each AI is contained in K for all I belonging to I. Now what does, अब हमें क्या शो करना है? We have to show this is contained in this. So how to show this is contained in this? Union I belonging to I, AI is contained in K. How we will show that? So we pick any element in this. Okay, so कोई भी x उठाया हमने in this set, तो वो K के अंदर शो करना है. कैसे शो करोगे? Now let x belonging to union I belonging to I, AI be any element. So now how you will show that this x belongs to K? Yes, बहुत इजी है, बताओ जल्दी. अगर x यूनियन के अंदर है तो उसका मतलब क्या है? If x belongs to A union B, what does it mean?
X belongs to A or X belongs to B.
Yes, x is either in A or x is either in B. So अब यहाँ पे x is belonging to this AI, so what does it imply? X belongs to AJ for some J belonging to I, right? किसी एक में तो होगा, इन AIs में से किसी एक में belong करेगा x, right? And this implies x belongs to K since AJ is contained in K from star, right? So this implies union I belonging to, या इसको next page. Since x belonging to union I belonging to I AI is arbitrary, it follows that union I belonging to I AI is contained in K. So this implies union I belonging to I AI is least upper bound of S, that is this is equal to union I belonging to I AI which belongs to Px. It is a power set of X. ठीक है? By duality principle, this which is equal to intersection I belonging to I AI, and this also belongs to Px. Hence, Px with containment relation is a complete lattice. Is it clear, everyone? This proof?
Yes, sir.
Okay, great. So अभी हमने करा कि we took the complete this power set. अगर हम क्या करें, कोई भी any collection of set ले लें, ठीक है? Remark or definition you can say lattice of sets. Okay, so how it is defined? Let X be any set, any non-empty set okay, so we have taken any non-empty set X. Let this be any non-empty subset of Px. Okay, so power set of X. So it is non-empty, means it is not there are at least one or two sets in this. Is it fine? Then this is called lattice of sets if it is closed with respect to union and intersection. What it means by being closed with respect to union and intersection? Yes, what does it mean?
If we take any two elements from Z, their union and intersection will also belong to Z.
Yes. So this is tau. Okay, toy. So and how when it will be a complete lattice? Also, this tau is called complete lattice of sets. When it will be complete lattice of sets? If it is closed with respect to आर्बिट्ररी यूनियन, ठीक है, दो का नहीं, आर्बिट्ररी यूनियन एंड आर्बिट्ररी intersection. Fine, is it clear? Do you need more explanation to this, or is it clear? Close with respect to arbitrary union and arbitrary intersection का मतलब पता है, and close with respect to union and so it means that is for any AB belonging to tau, A union B and A intersection B, this belongs to tau. ठीक है, so this is what it means by being closed with respect to union and intersection. And arbitrary union and arbitrary intersection का मतलब क्या है? That is for any family of sets, family I belonging to I of sets in tau, union I belonging to AI and intersection I belonging to AI lies in tau. ठीक है, so it arbitrary close with respect to arbitrary union and arbitrary intersection का मतलब ये है कि कोई भी तुमने arbitrary sets उठाए, so उनका union करोगे, that is again in tau, and if you take any arbitrary sets then again it is in tau, so that's why it is called complete lattice, क्योंकि यही हमारा आता है, जो सुप्रीमम आता है हमारा ये आता है, इनफीमम हमारा ये आता है, so that's why it is called tau, वो complete lattice of sets means it is subset of, it is not complete px, it is subset of this. Same proof will have, if same proof will be there, that's why it is called lattice, complete lattice of sets. ठीक है, is it clear?
Yes, sir.
Okay, now what about this ordered set Mn? The ordered set Mn, Mn क्या होता है हमारा? What was Mn? Yes, what was Mn? 1 n bar 1, right? This was Mn. The ordered set Mn is a lattice. ठीक है, ये होता है generally Mn. If you so इस तरह के lattice पोसेट को Mn कहते हैं, ठीक है, so this is your Mn. Clear? So the ordered set Mn is a lattice. चलो इसका प्रूफ बताओ. लैटिस शो करने के लिए क्या करना होगा हमें? लैटिस शो करने के लिए क्या करना होता है हमें? What is the definition of a lattice? When you call a poset to be a lattice, what was the definition of a lattice?
For any pair of elements in that set.
Yes, their supremum and their infimum should be in that set, right? So we will pick any two elements. So let xy belonging to Mn be any two arbitrary elements. So now we have two cases, either x and y are comparable or x and y are not comparable, right? So case 1, x and y are comparable. Okay, so without loss of generality, assume that x is related to y, because same thing will happen when x is or y is related to x. Then x cup y will be equal to what will be x cup y, and what will be x cup y? Yes, x cup y क्या होगा? x join y.
Y.
Y, and this is
X.
x. So it belongs to Mn, right? Case 2, when x is not comparable to y, that is. So where these x and y will lie in this Mn? Because if you can see, this element is related to every element of this set. Again, this element is also related to every element. But every element is related to, so if they are not comparable, that means they will lie in this chain, right? X and y can lie only in this chain. Then xy belongs to n bar. Yes, because this element is comparable with every element. Again, this element is also comparable with every element. So x and y has to lie in this chain, this anti-chain, right? What does it imply? So x cap y क्या होगा then? And x cap y will be, this will be top element of the set and this will be bottom element of Mn. Yes, this is your top bottom element, this is your top element. ठीक है, so it will belong to, so x कोई भी हो इनमें से x और y, तो उसका cap करोगे तो it will come out to be this, और उसका cup करोगे तो it will come out to be this. Clear? Hence in either case we see that x cap y and x cap y lies in Mn. Thus, Mn is a lattice. Fine. So is this proof clear to everyone? Why this Mn is a is a lattice?
Yes, sir.
Okay, in fact, you can show that it is a complete lattice, because again it will be the same proof. So agar koi bhi, if you have some element, if this top element is there in those, is in that arbitrary set, then your cup will be this and bottom is this. So किसी का भी cup करोगे तो it will come out to be this, किसी का भी cap करोगे तो it will come out to be that. ठीक है? This show that, okay, take this as a question for assignment. Show that Mn is a complete lattice. ठीक है? So this you have to show yourself. Okay, now next. Show that and not with this set of, and not क्या होता है? Set of non-negative integers. मतलब कि natural numbers में zero include कर देते हैं. Non-negative integers with divisibility. So usual less than equal to नहीं है, it is divisibility is a complete lattice. चलो अभी you just prove the lattice, and complete lattice you can take it as an assignment. Okay, बताओ. Yes. So how you will show that it is a lattice with divisibility? So it is not a chain, ठीक है ना? Chain तो है नहीं ये. So अगर चेन होता तो we could have directly said that it is a lattice, क्योंकि with usual less than equal to it is a chain, but यहाँ पे our relation is divisibility, so with divisibility it is not a chain. So now how we will show that it is a lattice? कोई भी दो उठाएंगे हम x and y, right? So what will be x cup y? डिवीजन में x cup y क्या होता है? I've already explained this to you. What is x cup y when there is division, and what is x cap y? So let
Sir, cup is LCM and cap is HCF.
yes. So
D.
let x y belongs to be any two elements. Okay. Then claim x cup y is equal to GCD of xy, right? Oh, sorry, LCM of xy. And x cap y is equal to GCD of xy. So एक ही show करेंगे, other can be proved on the similar lines. So let k equal to GCD of, oh sorry, LCM of xy. So हमें show करना है x cap y is equal to k. So कैसे आएगा? So you have to show x k is an upper bound for this. So how k is an upper bound? K is a LCM of x and y. So what does it imply? X divides k and y also divides k, because k is the multiple of both x and y. So this implies x is related to k and y is related to k. So this implies k is an, yeah, k belongs to xy set of upper bounds, right? xyu. Now next what we have to show, it is the least upper bound, right? So we will take let m belongs to xyu be any upper bound of xy. Okay. So that, what does it imply? This implies m is an upper bound, so this implies x is related to m and y is related to m. And what does it imply? This implies x divides m and y divides m. And what does this imply? It implies that LCM of x, so k, which is equal to LCM of xy divides m, because LCM is the least common multiple of x and y. So m is a common multiple of x and y, so k will divide m. So this implies k is related to m. So hence k is least upper bound of xy. So this implies k is equal to x cup y. On the similar lines, it can be shown that x cap y is equal to GCD of xy. So thus x cup y, x cap y belongs to and not. Okay, so this implies and not with this is a lattice. Assignment question to show that and not So with divisibility. Is a complete lattice. ठीक है, so ये तुम्हें खुद करना है, that it is a complete lattice, that you have to show yourself. Okay. So okay, we have time, so we can do one more question, one more example. Show that for a group G, the set of subgroups with inclusion relation is a lattice. So how you will show this? Yes, what we have to do in this? Sub G is set of all subgroups with containment relation, right? So it is a poset, we know this, we have already done this, that it, because with containment relation any collection of set will form a lattice, will form a poset, right? Now what about lattice? So what we have to show? Yes, we will pick any two. Let hk belongs to sub G be any two elements. So what will be h cup k and what will be h cap k? Yes, h cup k क्या होगा? Which is the smallest set that contains both h and k?
Cyclic subgroup generated by H comma.
Okay, so जैसे अगर हमें दिख रहा है कि h union k, right? H union k. So but it is not a subgroup of G, right? So it does not belongs to this. It may or may not belong. There are conditions under which it belongs and there are conditions under which it does not belong. So now we need the smallest subgroup that contains both h and k. So what is the smallest subgroup? It is the subgroup generated by h union k. Okay, because we want it to be in sub G. ठीक है ना? Is it right? And what will be h cap k? Yes, what should be h cap k? This can be h intersection k, because intersection of two subgroups is again a subgroup, but union of two subgroup need not be a subgroup. So we take the smallest subgroup that is containing both h and k, and it is the smallest subgroup that contains both h and k. ठीक है ना? देखो सेट्स के केस में हमारा h कप के, जो कंटेनमेंट रिलेशन के केस में हमारा h कप के क्या था? It was just h union k, but because now our set is a collection of subgroups, so जो union आएगा that may not be a subgroup. So to make it a subgroup we have to take the cyclic subgroup generated by h union k, or we can say the smallest sub. Is it clear everyone?
Yes, sir.
So we have to show that we know that h union k is the smallest subgroup of G such that contains both h and k. That contains both. So by definition ही, क्योंकि ये contain भी कर रहा है, so it is an upper bound and it is the smallest. So कोई और subgroup होगा तो that it will be contained in that both h and k. So this implies h cup k is equal to h union k. Also, since h intersection k is the largest subgroup of G which is contained in both H and K, hence H cap K. So ये दोनों स्टेटमेंट लिखनी है हमें, ये हमारी ग्रुप थ्योरी से आ जाती है अपने पास, ठीक है. So this belongs to subgroup of G, this belongs to sub G. So thus sub G is closed with respect to union, with respect to join and meet. Hence sub G with containment relation is a lattice. Clear everyone?
Yes, sir.
अच्छा, अगर मैंने नॉर्मल सब ग्रुप्स लिया होता तो क्या होता है हमारा H कप के, which is the smallest normal subgroup that contains both H and K. Show that for a group G n sub G with containment relation is a lattice. Yes. So let HK be any two normal subgroups of G. So we have picked any two normal subgroups. Claim H cup K is equal to क्या होना चाहिए? Intersection of two normal subgroups is a normal subgroup, right? पढ़ा हुआ है ना, intersection of two normal subgroups is a normal subgroup. Yes. और जो दो सब smallest subgroup that contains both H and K वो कौन सा हुआ? Smallest normal subgroup. Yes. So this is HK. What will be this? This will be HK, which is the set HK, H belonging to H, K belonging to K. Remember? So it will be this set. So we know that from group theory, we know that from group theory, we know that HK is the smallest normal subgroup of G containing both H and K. So this implies H cup K is equal to HK, which belongs to the normal subgroup of G. Also, intersection, H intersection K is the largest normal subgroup of G contained in both H and K. So this implies H cap K is equal to H intersection K, which again belongs to N sub G. Hence, n sub g is closed with respect to join and meet. Thus, n sub g with containment relation is a lattice. Clear? Is it clear, everyone?
Yes, sir.
Okay. Now I want to give you a question in assignment. So 3 क्वेश्चन दे रहा हूँ, ये तीनों कर लेना. Draw the Hasse diagram for first sub d4, second n sub d4, third sub z2 cross z4, and fourth n sub z2 cross z4. ठीक है, एलिमेंट्स के साथ इसके सारे पहले सब d4 लिखना कि कौन कौन से एलिमेंट्स हैं, फिर उसके बाद वो सारे इसके वो लिखना. ठीक है, you have to draw this Hasse diagram for sub d4, n sub d4, sub z2 cross z4 and n sub z2 cross z4. ठीक है, तो 3 क्वेश्चन है असाइनमेंट में, ये कर लेना. And you have to submit assignment on Wednesday because tomorrow we don't have any class, so you can do these questions tomorrow. Date is, what is the date? 18th, right? So anyone wants to ask any question? Yes, any one of you who wants to ask any question? Okay, so there are no questions, so I will end this class. Bye everyone, have a nice day.
Thank you, sir.
Thank you for watching this video. Please subscribe to our YouTube channel, Online Learning, to stay updated and share with your friends. Happy learning through online learning. To watch more, click on any of these cards. Thank you once again.